I wanted to understand the universe. If aliens came down from space and landed, the most impressive thing on the planet would be like a particle accelerator or a fusion reactor or a quantum computer. There's some position that you can fit into in the world uniquely and perfectly suited to you. It was a grueling thing. And it was basically like the slow decline of like morale. I moved back into like my parents' basement in Canada. I thought that fusion energy was critical. Quantum computing is like a nice to have. All economic prosperity is downstream of energy abundance and energy costs. It was really started when I started writing stuff online. I had a couple thousand followers. Within a week, I went from 1,000 to 40,000, of the most prominent investors in Silicon Valley and engineers and scientists. They believe in this future. They believe in this kind of like artistic creation that we can actually completely reinvent what the world looks like.
Super excited to host today Andrew Côté, the founder of Deep Tech Week. Andrew, welcome.
Thanks, man. Good to be here.
It's great to have you. So today we're going to talk for 45 minutes around the entrepreneurial journey of Andrew. We're going to talk about Deep Tech Week, and then we'll finish with, are we going through a renaissance in the US thanks to Deep Tech? So Andrew, let's start with you. You've admitted it, you're Canadian.
I am, yes.
From British Columbia?
Yeah, Vancouver.
Vancouver, nice. And so you've studied in Vancouver, but it's not the only place where you...
Yeah. So my family came from France in the 1600s to King's New France, which was Canada. It's now Canada. But they came to British Columbia in the 1800s. And so my family really is from British Columbia. And I went to school first, actually, to study sociology and anthropology, and I finished that degree at McGill in Montreal. And then I worked in marketing and property development and kind of other kind of random things for a couple of years, and went back to school for engineering physics at University of British Columbia in Vancouver.
How did you? I mean, it's interesting because I can understand you a bit more now that you said you studied anthropology.
Yeah.
How did you make the switch from anthropology to becoming a physician?
Engineering physics is the name of the degree, and that's like the job title. So not physician, that's like a medical doctor. But it's kind of funny. I was like pretty bad at math in high school and elementary school, and I actually kind of sucked. And everyone was like, yeah, like you're a right-hand side of the brain guy. You're like creative writer, like love writing a lot. Towards the end of my degree in sociology, I just got more into physics as an interest. Cosmology and astrophysics were very interesting to me. That kind of stuff. I wanted to understand the universe. I wanted to bring my intuition for how things worked into closer correspondence and closer harmony with the evolution of physical law. And so to pursue that, I thought, if aliens came down from space and landed, the most impressive thing on the planet would be like a particle accelerator or a fusion reactor or a quantum computer. I wanted to work on that kind of stuff. I thought that would be, into the future, the most important thing to be a part of. And so I did like the opposite of the Thiel Fellowship, which is to drop out of school. Instead, I went back to school for like another undergrad degree, but this time in a very challenging discipline of engineering physics, which is a pretty, very broad degree. So it covers electrical engineering, mechanical engineering, a bit of software development, like data structures, algorithms, numerical methods, on top of a honors physics degree. So it was like totally grueling, absurdly difficult. But it got me to work on things like particle accelerators and nuclear fusion. So it's been
and let me ask. And so when was this? Just so.
I think I went back to school in 2014.
Wow.
And then graduated 2019.
The reason why I ask is I felt like 2014, no one was talking about deep tech. Let's put deep tech as like encapsulating everything you've said, and you're already asking yourself those questions.
I was, I'm very happy how things have turned out. Even in engineering school, a lot of my friends that were in the same program as me that were studying things like quantum mechanics and general relativity, mechanical engineering, they went and took very lucrative jobs in software companies. They went to work for Pinterest and Twitch and Google and that kind of stuff. And for me, I was really like those were, say, paid internships that make a lot of money at Google just for a summer. And I was taking like a way lower paid job, but it was working on like a cyclotron, like a particle accelerator. I was building like cool, like RF, satellite dishes for low Earth orbit constellations, or going down to Stanford at SLAC, working on like a particle beamline there. And so I was always very much like, I am into fundamental physics and advancing what is engineering, what is possible to engineer by understanding the frontiers of physics. And so that for a long time was not a startup category.
Yeah, for sure.
And when I went to school, initially there was like 3 fusion companies on the planet, right? Now there's like 45. So the beginning of the journey to go back to school for physics was like, wow, maybe one day I can like be like, working on a fusion reactor or something like that. And then, a couple of years ago, my last job in a technical field was senior design engineer for a nuclear fusion company. I was like the 6th employee. So that kind of came true.
So 2019, you graduate.
Yeah.
And with that degree.
Yeah.
And you didn't have the bug yet of starting your own business?
I did actually. In my last year of school, I was really into physics. So even as an undergrad, by the end, I was taking a lot of graduate courses in physics. And I was taking relativistic electrodynamics, which was really cool. Another one I wanted to take was like condensed matter physics. Instead, though, I dropped that for a course on entrepreneurship. And it was like, it's kind of like crash course, kind of like, simple thing for college students. But they team engineers up with business students. And I had so much fun doing that. For me, I got to finally combine these skills of like sales and marketing that I had done in the past that I was actually kind of good at with like this technical engineering problem solving. And it's all this narration storytelling, right? Like that's the thing I enjoyed the most. So when school ended, actually, I had a job lined up at Lawrence Livermore National Lab to work on plasma Wakefield accelerators or laser-driven plasma Wakefield accelerators, which is like the next generation of particle accelerators. I ended up turning that down so that I could try starting a company with some friends. And that company was kind of funny, but it was like, well, first we were going to work on this optical display that would produce a far field focused image to replace rear view cameras, right? Or sorry, rear view mirror displays. And so, a rear view mirror, it doesn't have a very wide field of view. It has blind spots, but your eyes can focus at the same distance as the outside because the light rays come from far away. If you replace that with a screen, the light rays are coming from close up. Your eyes have to refocus. People complain about these TV displays as giving them headaches, making them feel weird. Yeah. So it's kind of solving that problem. That ended up being more difficult. And my other friend...
What was the difficulty in starting this business? Was it consumers? I'm guessing the consumers were the auto manufacturers and...
Yeah, it would be auto manufacturers and consumer. We had a partnership with this Ferrari racing team, which is kind of this glitzy thing we thought was cool. So the technology used for this is called computational imaging. And specifically what we're trying to do is build what's called a light field display. And so a light field display has full control over both the not just the pixel color and intensity like a normal display, but the angle at which the ray from that pixel goes.
Yeah.
And so if you can control both the ray angle as well as the color and intensity, then you can produce images that may be close to your face, but look like they're from far away. You can produce basically like this kind of hologram effect, right? So this field was...
That's a multi-$100 million type of fundraising company before you can produce anything, no?
Yeah. Well, there's a couple companies producing these things. One is actually out of Europe. I forget the name, but they're probably the world leader in it. It looks more like a PhD project, less like a company, right? And that was kind of some discernment there and like how much tech risk is there.
And that was in Vancouver?
Yeah.
Okay, with your two buddies or colleagues?
Yeah, a few friends from college, yeah. We all end up pivoting into something else to try, which was using like an Xbox Kinect, which is like a 3D tracking thing to track people's workouts. That was actually my friend's project he had built in the past. That was like his capstone engineering project. My capstone engineering project was like a magnetic coil system to test superconducting radio frequency cavities used for particle accelerator design. And so that was like not a company. His was a company. So we tried to work on that. At the same time, I was working as a consultant in this university incubators, kind of bouncing between different startups there. They were like, 6 months or 1 year in. And I was like a technical intern, basically like doing like, firmware development or hardware design.
Sure.
So actually, yeah. So right after school, I basically canned my grad school plans and research in physics to be like, let's try the startup stuff. And I kind of bounced around a couple ideas, a couple different companies.
You sound like you have a lot of ideas.
I certainly do. Yeah.
How did you focus on one specifically or?
Well, actually I didn't.
Right.
So initially I was just like trying a bunch of different stuff and seeing what worked, what didn't. And none of them really took off. They didn't really go anywhere, didn't have much traction. And I realized, if I want to work on something big, like I didn't really care about the gym industry and fitness, right? Like I wanted to work on something that was like much more cool or big that could kind of harness like my interest in applied physics into the frontiers of technology with this kind of entrepreneurship and that kind of stuff. And so I just thought I have to get to San Francisco. I just have to get to San Francisco. This is the place to go. And so I kind of, for the first time in my life, I kind of was like, okay, let's just find the job that matches the right search parameters as opposed to being like my most passionate thing,
Sure.
like, fusion or something. So October 2019, I got a job with a infectious disease nonprofit called Zuckerberg Biohub on their bioengineering team, which was a big jump from accelerator physics. Now building like low-cost open source instruments to do pathogen discovery in the developing world.
And so you moved to San Francisco.
Yes.
To start specifically
this job and bioengineering,
which is different than what you used to study.
Yeah.
But it's definitely one of those I can see like passion you were probably trying to solve.
It had the right characteristics. It was a worthy mission, like low cost, open source pathogen discovery, infectious disease research. This is like good for the world. It was a nonprofit organization that had strong academic ties, so it could like keep open this like grad school thing that I was kind of on track for before. Okay. But it was also more like an engineering team. So it was kind of a bridge between industry and academia. I wasn't in a lab, like a university lab. It was like a well-funded organization. And because of this configuration, I thought it had the potential to spin a company out in the future, right? Which was kind of part of my background thinking. And within 3 months, the COVID broke out, and suddenly infectious diseases was an important thing to be working in. And so that's a whole story we can get into. But basically 2 years later, I tried spinning a company out of that nonprofit that was an early application of large language models, kind of before ChatGPT.
So you stayed for 2 years. I was going to ask you the question, can you stay still as a lab researcher?
I really enjoy engineering. I actually have a lot of fun building stuff. Like some of my most fun times in my life have been like 2 a.m., like 13 hours in, machining stuff, debugging electronics. Like it's really enjoyable.
Is the passion, deep tech, it's funny because a lot of people ask me, they're like, are you an impact fund? And I say, I'm not impact. We're deep tech. But deep tech to me, to the core, it's you're trying to achieve something for humanity to make humanity better. And sometimes they're like, well, you don't say it. I'm like, it's deep tech. That was your first criteria when you joined the company.
Yeah.
Is it something, and we'll get to what you do now, but what do you think about this? What do you... You've probably thought a lot more than me.
Yeah,
about
maybe. Well, I don't know. I think about a lot of things, but I would say there's maybe my very rough framing is there's kind of like one dividing line between like things you can do in the world. There's things that you can do that if you did not do them, no one else would, or no one else would do it the same way. By dint of your birth in a social graph, in a particular time and place, by dint of your acquired skills or your natural talents, there's some position that you can fit into in the world uniquely and perfectly suited to you. On the other hand, there are things that if you did not do them, someone else would in exactly the same way, because the performance of that function is defined by how you do it. And that is like before going to school for engineering physics, my plan was to be a lawyer. Okay. And so I was like, but then thinking about that, like, well,
yeah, you would have been that.
I would have been like, just your job is to do this thing exactly this way. And you're competing with other people on who can do it just that way. And so I could never do this job that is like, I'm like the opposite of a corporate guy, I can't stand that. I hate it. I'm too weird or whatever.
So you wanted to identify with the first group, which is, it's the first time I hear it, and I understand it. Do you mind me asking, what do your parents do? Is there something in was one of your parent a model for this thinking? Are you one of many siblings, or what's the...
I don't
Or
know.
is it just you?
I don't know where this thinking came from.
Is it Vancouver?
It's not a Vancouver thing. Vancouver is not necessarily like this. This is just, I don't know. This is how I think about things.
Yeah.
This is how I think about things. I've thought about this from a very early age.
I mean, yeah.
But I was a weird kid. I was reading like Stephen Hawking black hole stuff when I was like in grade 7. So I don't know.
Yeah, I mean, I mean, it makes sense, right? It's reading. Even the name of your company now is kind of a pun. No, not a pun, but a kind of a sign to a famous reader. No.
Hyperstition Incorporated.
Yeah.
Well, that's. I mean,
we'll get there.
We can get into that. Sure. Sure.
And so wait. So 2 years at Zuckerberg.
Yeah. Chan Zuckerberg Biohub.
Chan Zuckerberg.
Yeah.
You decide to try to spin out a business.
Yes. This is with the same friends from college that we worked on the car display project and stuff. Well, we really got along as a team. We were really, so since then, my one friend, Andrew Dorshak, he had gone to Stanford to do a kind of master's of business engineering. The other guy, Grant Robinson, he had gone to work in an early stage startup, helping it grow from 5 people to 80 people. And so meanwhile, I was in like a technical lab place. And so we kind of had the perfect combination, like me on the engineering side slash the problem and the nature of the problem and data management for early stage drug discovery. The other Andrew in the business and Stanford world, Graham being like early stage startup growth guy. Like we kind of had a great sort of complement of skills and interests. And so that was, I got involved. It was really a case of intrapreneurship, right? Working inside an organization to uncover a problem, characterize it well, talk to people that experience this a lot. And because it was a nonprofit, it was very favorable to spinning this kind of stuff out. Like the senior leadership was very kind. They were helping me. They were giving me advice. Like the CTO was an advisor to the startup, and it was kind of with the blessing of the organization. Yes, like we'll help you, whatever. So
is this one of the cases where, because it's a nonprofit, you can kind of say,
yeah,
I'm thinking of this idea, and
totally.
So I would love to kind of focus my work on maybe spinning this out.
Yeah. People were very friendly about this, and my engineering manager, he was very nice about it. So it's kind of like building the ramp, right? Getting a few customer relationships or associations with labs, and the product there was really, early stage drug discovery is so chaotic, and it's in the design of experiments, you cannot actually formulate what a database schema will be for all the interesting information you might want to acquire before you actually know exactly the questions you're asking. And in the discovery of targets and molecules that can bind to them for the treatment of certain diseases or the blocking of pathogen infection, you actually there's so many unknowns at the beginning. And so basically all the information collected in early stage drug discovery is completely unstructured.
Yeah.
It is completely a mess of like notebooks and random Google Docs and Excel sheets and this kind of stuff. And so LLMs were like the ultimate sort of ingestion or, ETL layer that could deal with this like mess of garbage data and then try to put it into some kind of database. And so, but we were trying this in like, I guess 2021 or something.
Before but transformers existed.
They existed, and like GPT-2 was out and BERT and stuff, but they weren't like working that well, and so it was kind of too early. I think I would also more honestly like we didn't really know what we were doing in a big sense. We didn't really know how to use them in a way. The problem was very nebulous. Our definition, articulation of that. We spent a long time trying to raise an initial round of funding. We had a few angels that supported us. A lot of people, like the most honest feedback we had was like, you seem like a great team, but the problem you're working on is not the right thing. And we learned that in the biotech space, basically all the money either comes down from data acquisition modalities like single cell sequencing or assignment of royalties to the actual therapeutic that's developed.
Not necessarily like a digital tech layer.
Yeah.
You're kind of in between, right?
It's this classic thing. I think it's like, it's a painful problem to experience, but it's not a valuable one to solve.
Yeah.
Because the people who experience it tend to be like, they're not high paid or it's just part of business. It's like, oh yeah, of course our early stage records are a mess, but that's not where all the money is. All the money is in clinical trials. All the money is in, the commercialization steps. So yeah.
Okay. And so it took you what? Took a year for you to realize this, and then
it was like a year and a half, and like it was a grueling thing, and it was basically like the slow decline of like morale, and like I like exhausted all my savings. I moved back into my parents' basement in Canada. Like it was like months and months of that, of like trying to grind through more meetings and more meetings. And eventually I just like, me personally, I was like the weakest link. I just like bailed. I was like, I just can't do this. It's
really,
not
you were
working.
this time you were the first one to go.
Yeah. I told the guys this, and it was like, it was kind of a long time coming because it was like a slow decline. And I mean, it was for the best. Like they pivoted into something else, doing like AI and NFTs, and within like a few months raised $5 million, and we're off to the races. Meanwhile, I was like, oh my God, I'm so depressed. So I just like I just had to get back to SF. I just knew it. So I took like a job at this, like, it was not a startup. It was what you'd call like an SBIR mill, like a 20-person company off the side of the highway, building beam-driven fusion devices for boron-neutron capture therapy, which is a way of treating rare cancers where you irradiate a tumor that has been dosed with boron with neutrons of a certain energy to form a short-lived radioactive particle, or short-lived particle like an alpha particle.
It's become a pretty common treatment for...
Oh, has it? I don't know.
I'm asking you.
No, it's pretty rare. It's pretty experimental, but there's a lot of interest in doing it because it's the only way of treating certain kinds of cancer.
Okay. Well, you came back into what you love the most, right? Achieving something that's good for humanity.
Yeah, it was like, I mean, for me, it was like, I wanted to get... I remember this very distinctly. It's very funny. The company was obviously failing, the startup, but it was like kind of, I'm on my way out, like hang with my co-founder, and he's like, what are you going to do next? And I was like, I don't know, dude, maybe I'll get like a grad degree in plasma physics. It's Princeton. It was like PPPL. That would be cool. I kind of thought I want to work on either fusion energy or quantum computing. I thought that fusion energy was critical. We need that energy. Quantum computing is like a nice to have. It's not as integral to our civilizational prosperity.
Why? I mean, because one is abundant energy. Isn't the other one solving physical problems?
Yeah.
It's a non-engineering way to summarize.
There's a lot of places you could use quantum computing to solve things that would be miraculous unlocks, like in material science and synthetic drug design, which are kind of like, far looking. But energy is more fundamental. All economic prosperity is downstream of energy abundance and energy cost. And in the limit of a perfectly designed energy production device, the marginal cost of energy is the cost of fuel that goes into it. Yeah. And so in that sense, the fusion will be in the future, unless we crack like 0-point energy or quantum vacuum or something esoteric, it will be the cheapest energy cost in the future.
So you're saying the first thing we should crack is abundant, cheap, free energy.
Yeah.
That's when
energy as cheap as possible, and I mean, solar is obviously amazing for space.
You got retweeted by Elon Musk on a solar tweet, no? I saw a tweet that Elon Musk, was it solar or?
It's been a few of them.
A few, sorry.
He's great. Well, he's very aligned. He is like the most aligned dude in the sense of like, we need to build the tech stack of the future, right? Yeah. And I think that's like what I'm all about, I think.
Do you believe and then we'll get to Hyperstition, do you believe we're 10, 15 years away from limitless free energy? We're 50 years away? We're 100 years away? Is this a world where we're going to live one day? Is it too deep of a question or too vague of a question?
No, I think it's possible. I think it's completely possible. And I mean, the goal of nuclear energy in the 1950s and 1960s was energy too cheap to meter. It was to remove energy from the cost equation of like, what is the cost of doing business, right? And we could have probably had that if it had not been for these nuclear accidents that led to a regulatory sea change, which made additional megawatts of nuclear capacity more and more expensive to build in the West. And so the anti-nuclear campaign, the anti-fission campaign, often was funded by oil and gas companies operating through these environmental front ends. And just as a side note here, like my uncle was one of the founders of Greenpeace, which started off protesting nuclear bomb testing and then graduated into protesting nuclear power more generally, which I think was like not the right move.
It's funny. I don't know if it's true, but I read another tweet where it said that apparently the CIA put a little research report back in the 60s saying it's likely that France would become one of the strongest power in the world because of their high focus on
Oh my God. Yeah.
nuclear energy. And unfortunately, they just fumbled that over the past 20, 25, 30 years.
France has?
Well, I mean, in the sense that they haven't really pushed it further.
Mm.
They haven't. Let me get this straight. They became. If it wasn't for nuclear and energy today, France wouldn't be where it is right now.
Oh,
but
totally.
they could have gone a lot
Right.
further. They got slowed down by the same kind of movement you mentioned.
Well, so France has done a couple things really well with the administration of its nuclear energy program. And the main thing is having a dedicated professional civil service that goes around building nuclear reactors. Right? There's this great line that I heard in the fusion industry is that in America, there's like 3 kinds of cheese, and in France, there's like 1,000 kinds of cheese, and it's flipped when it comes to nuclear reactors, right? So in America, nuclear reactors are built like airports. Everything is a new construction with local contractors, all this kind of stuff. Whereas in France, it's like it's the same people building reactors again and again. So they get better at it. They get better at administrating it. They know how to operate it. It's the same playbook. And so they have like 80% of the grid powers from nuclear versus Germany, which has had a disastrous energy policy, completely self-destructive.
And they've closed the last nuclear.
It's so dumb. It's so dumb. And if you look at actually like the composition of the German energy grid, the closure of nuclear power plants has been perfectly compensated for by the uptake in gas-driven turbines.
Yeah, sure.
So it's just like, oh my God, like their cost of energy is going up, their industry, manufacturing is suffering, all this kind of stuff. So energy is important. Yeah.
And even if you take into account the environmental impact, I mean, it's gotten worse.
Yes, their energy is dirtier than France.
Because a lot of people don't think that nuclear energy is decarbon.
That's also completely wrong. If you look at like how many tons of steel and concrete or material consumption or land imprint it takes to deliver a megawatt of energy, nuclear is by far the most efficient. Solar like solar is marginally cheaper per installation and cheaper en masse because of the regulatory environment, but it is so costly in terms of the steel, silicon, copper, silver, and the land footprint. And so nuclear is by far like the most efficient in that sense.
So one thing I didn't mention is, I was looking forward to this podcast because with Andrew, I think we can go on endless tangents.
Oh, sure, yeah.
Endless subject, because the subject I think we both love. Let's get back to you. Let's get back to this job that you got off the highway. And how did you come to Hyperstition? I think, and Hyperstition, by the way, is a company behind Deep Tech.
That's right, yeah.
So I think I have an idea now how you decided to launch Deep Tech Week, but what happened exactly with you? And
it's actually way more hilarious than you'd think. So the job off the side of the highway was really for me because I wanted to get back into the game for physics, and it was a good first step. And I had fun working there, actually. It was nice just to do technical work again after trying to like sell databases to life scientists. But that really was like a stepping stone to getting a job at a nuclear fusion startup out of Princeton called Thea Energy, originally called Princeton Accelerators. But that was like the dream job. It was like designing accelerators, and like I got to do a lot of design work and simulations. It was a lot of fun.
So we're talking about Princeton, New Jersey.
Yeah.
Okay.
Yeah.
So you were considering actually moving to Princeton, New Jersey, because that is where.
Yeah, it was a remote job to start. So I was thinking about moving to New York, and ended up staying in SF just because I was like, kind of gave it another shot. It was really started when I started writing stuff online. I started using Twitter when Elon Musk was buying it just because I thought it would be entertaining. But then I started to write more online too. I really enjoy writing, and I started to grow an audience around technology, around physics, explaining cool stuff. It really picked up with this whole LK99 saga. That was like this room temperature superconductor.
Sure.
That kind of me and a friend, Ryan McIntosh at A16Z, he kind of like started that. He posted some kind of article about this topic. And a couple months before, I had written this thread about superconductors and how many things would become unlocked as we produce superconductors that work at higher temperatures. And then some other dude that kind of followed us both wrote that first viral thread that kind of kicked it all off. And I was like hanging out with Ryan at like Shack 15 in SF one afternoon. And I was just like, I had like, a couple thousand followers. He had a couple thousand followers. And I was like, okay, I'm going to compete. Let's compete. Like who can write the most shit on LK99 to get whatever. And so I just like locked in and wrote a bunch of things, and they all went crazy viral. And overnight, I within a week, I went from 1,000 to 40,000, but it was like 40,000, of the most like prominent investors in Silicon Valley and engineers and scientists. All these people were reaching out. Oh my God, leading voice and understanding L-Canadian. That's kind of a weird thing. But I mean, at the time, I was a superconducting magnet design engineer. Previously, I had worked on superconducting RF cavities for particle accelerators. I knew how to write stuff. I knew how to market. And so that kind of how I built my initial social media following. And then I had a lot of VC funds reaching out, looking to hire me. And I was like, this is interesting. Maybe I should think, I was kind of like looking for new things to do. The engineering job was awesome, but the company was growing in New York, right? And I was not in New York. And so it was kind of like, well, if I want to stay in SF, I should probably figure out something else. And that's kind of the beginnings of Deep Tech Week, right? So I'll give you the unfiltered story because it's kind of funny. But I had a job interview with Founders Fund in Miami, and I didn't want to move to Miami, right? Miami seemed incredibly fake, full of like OnlyFans and crypto grifters, which I think is incredibly true. And it was only ever popular during COVID, and everyone that's moved there to try to build the tech ecosystem there has essentially left. Not that they don't have their own tech ecosystem, but it's not the same centrality as San Francisco. So I thought, okay, well, maybe if I do a Deep Tech Week in San Francisco, this could like get me a cool venture job of some kind, right?
Another one.
I don't know. Yeah, sure. Why not? Right. So that was the ploy.
Wow,
and so it started off with like 5 events and just kind of getting people I knew interested. But then more people got interested and turned into throwing this crazy party on this aircraft carrier, which was like, it was kind of weird because that was like the first event I ever produced.
By the way, just so that in case people all know that, Deep Tech Week.
Yeah, it started with this thing.
Right. One of the landmark event is this party on this aircraft carrier in Oakland or Alameda or...
Yeah, in Alameda, the USS Hornet. Yeah, it's such a zany thing. It's kind of like hard to believe it came together. But like, my friend Sam Preedy was helping, my friend Simone. Other people were kind of piling in with this momentum that I think you can only really pull off here. It's like people here are all about momentum. They're all down to chip in. They just love a good time.
They love something unique too.
Yeah,
it's not like your endless cheese and wine party to meet deep tech, thinkers.
Totally.
Something different. I mean, I think people are looking for something different.
Yes, this was certainly different. We had this aircraft carrier. We craned in like some modified Cybertrucks and this like DeLorean from Back to the Future onto the flight deck. We had all these robots. I had this is part of the story. So we had a couple sponsors, but like a bunch of Cybertrucks parked and DJs and live shows, and then hardware companies showcasing their stuff. And the whole thing was like, I was like not sleeping for 3 weeks. I was going crazy. It was so stressful, barely keeping it together. But it was like such crazy hype. The Deep Tech Week thing just exploded. There was like Jared Freeman, YC partner, showed up at the door and he was like, this is crazy. We should get involved. And I was like, yeah, sweet, awesome. Sergey Brin, his girlfriend, showed up. I gave them like light up glasses. Welcome to the future. It was one of these things. It was like so absurd. So the week kind of blew up overall, and then I tried to throw a big closing party as well. But this is my first time doing it. So essentially, the whole thing was just like financially ruinous. It was like absolutely all these debts and stuff, and I was like so plagued, and I was like, oh my God. So I thought, okay, you know what? I think I just have to like make this business work and figure it out. And there's forget the VC job, forget the venture-backed startup. We are now bootstrapping an events and media company.
Right.
From negative cash balance,
it's ideally, but it's funny. You launch a movement, I think, and the funny thing is, it's kind of like what we expect from entrepreneurs. Rethink the model of what they're operating in. You're definitely rethinking the model of what a conference should look like.
Yes.
Can you go a bit into details as, this decentralized approach to your model?
Yeah, absolutely. Well, I'll start by saying it's not exactly original. Like the Tech Week concept has already been around a little while, right? Where people are just kind of decentralized. But I think with, deep tech as a category, the only conceptually coherent thing tying all these disparate industries together is perhaps the willingness of investors to underwrite significant engineering and technical risk, right? Like nuclear fusion has like nothing in common with biotech. And these things are very different from aerospace and satellites and all these kinds of things. But the kind of people that like to build those kinds of things have something in common, which is that often perhaps in the past, they were not really motivated by money. Like you don't go into satellite design because you think you're going to get rich. It's like extremely hard. And like you would have taken that job at Pinterest or Google or something like that, right? So they have a common passion that ties them together. They have
Are you talking about the investors?
I'm talking about the founders, the people that work in this. I found a lot about the investors as well, because they're also kind of like, there's obviously easier businesses to underwrite. Right. But they believe in this future. They believe in this kind of like artistic creation that we can actually completely reinvent what the world looks like, as opposed to just find a place that's lucrative to apply the latest database or something like that. So the culture has this kind of unique thing. And I think this decentralized conference concept, it's really like, well, each day of the week can be around a different topic. It can be around biotech or defense, and those people have their kind of tribe, but they have this kind of common like ethos and creativity and like passion for creation and original thinking. And so that's kind of like why it's so decentralized. It's like anyone can host an event as part of Deep Tech Week. Default, everything is free to attend. It is really a hype and marketing. It is the ultimate. It is, in my mind, it's like the positive sum game you can play. Look, by everyone doing something together in the same time period under the same kind of very neutral umbrella that does not try to claim credit for what they do. Like, I don't run a fund. I'm not competing with anyone. It's literally just to get everyone together. Everybody wins as a result. You know, people, I know in SF it's worked, and in New York it's kind of worked. People fly in from all over the world for this week, right? It's awesome. The more everyone piles in together, the more everyone wins. And I think that is like a good ethos for how we build the future as well, how we take risks together. You know, you got to band together. And, you know, it's like, yeah, it's kind of funny because now I never would have thought I'm going to like run an events company and it's going to, you know, and like I'm really good at storytelling. I help other people raise money by telling them how to tell their story. And, you know, like, it's just me bootstrapping this thing from scratch.
And I think you're enabling a lot of your passion, what you want to achieve. You're achieving it through this movement, through these conferences. I mean, getting the right people to meet, getting the right people to fund one another, getting the right people to work together. I mean, I'll tell you something. The reason why, so we're a Paris-based the deep tech fund. We invest all over Europe, right? And in our mind, we're like, okay, San Francisco Deep Tech Week is the one conference we need to go.
Yeah.
The entire company last year in June came to San Francisco, and it's here that we realized we need to open an office here. So if I'm here now and we're doing this podcast, I think it is thanks to you in a way.
Yeah, that's awesome.
So you're enabling this, and the truth is you're enabling us to keep investing in those crazy deep tech ideas.
Yeah.
So if we the last part of the conversation, I'd be curious to hear. So you've created this movement. It's in San Francisco. It's in New York. It was in New York. No,
it's in New York in the end of March. And actually, it's going to go to Austin, Seattle, Berlin, and Washington D.C.
Do you expect the same turnout as San Francisco, or they're going to be a bit more specialized on what these cities kind of cater to in terms of deep tech founders?
I expect it to become extremely large and massive
everywhere.
And I see this not as just a guess. I think it's inevitable, and there's reasons for that. And you only have to look at like the destruction of valuation in the publicly traded SaaS industry just to understand that the frontier of atoms and physical technologies is the only truly long-term sustainable competitive business advantage that you can have. And that the companies that develop new technologies will ultimately be thousands of times more valuable than companies that just use technologies. So deep tech has always been, it's Silicon Valley, it's the transistor.
Sure.
It's not, software has been a temporary distraction, and we now put our shoulders to the wheel of building genuinely new things. So I think Deep Tech Week is just, my intent is to bring it everywhere, to create the kind of conduction valence band of people building this cool way, to keep it kind of open source and decentralized.
Do you think that, so you're saying it's the future of everything, it's going to be creatively destructive? Do you think that actually 5-10 years from now, none of us have a job, and actually it's just AI minds doing this research work, doing this innovation work, doing this? Are we at this curve where, do you have a specific conviction on the subject? Or?
Yeah, I've thought certainly about this. You know, So, like, the long march of technological progress has net always been to uplift humans from toil and drudgery towards greater and greater degrees of agentic creativity and productive leverage. And AI is no different.
Right.
Yeah. So, you know, it's helped me do things massively. Will AI produce all the art? Will it produce all of the romantic relationships and this kind of stuff? I think no, actually, and I think you know it will eliminate scarcity of so many things, but there are certain markets that are always zero sum, and I think attention markets are one. Social status and social connectivity, social capital is something that cannot actually be replaced by AI. And so one of the reasons I'm like building this events media thing is because it's based on my premise that I think the one thing AI cannot compete with is your social identity.
Yeah.
Ever.
Yeah. It's interesting. Your startup is something that it's AI proof in a way. Humans are looking for other interactions.
Oh, totally. Yeah. And I think the demand for in-person connection will only go up as like the degree of fakeness in the digital world increases.
Yeah, good point. I didn't mean this in a negative way. My question. I meant it more. 10 years from now, maybe we're all working. A few hours a week. To your point, and then the drudgery is done by someone else.
Totally.
And that includes all these painful research to solve the next problem.
Oh yeah, I think like the speed with which we can get things done is only going to go up in time. And so what we get to work on becomes more and more what we want and less what we have to. And it's funny how we feel this threatens the fabric of society. Like wage labor is maybe 200 years old. Like with the Industrial Revolution, with the Enclosure Act, before that, you live on farms and your ancestors lived on the same farm and you have a lineage, a feudal right to work on this farm and the local warlord takes 10% or whatever, which is actually lower. It would suck to live under a warlord. Well, that's lower than like income tax or whatever. And so now we live in cities and we trade our time for money. And that is a completely like new thing in the history of humanity. And so for us to get all scared that wage labor is going away, well, the constraint on doing things just won't be money anymore. It'll be ideas, your ability to move resources, the availability of energy. It's those actual fundamental factors of production that are irreplaceable. Capital was always just a fungible asset to allocate those.
Energy. Let's go back to energy a little bit, because to me it is the number one goal we should go after. It's the one thing we should solve. I mean, you mentioned this. I'm not trying to copy what you said, but what are you most excited these days with with energy or energy development or energy startups? There is a crisis in Europe, so a lot of money is poured into how do we produce energy and stop being dependent on someone else's energy.
Yeah.
Is there something you're seeing here in this American Renaissance through deep tech with regards to energy in the US?
Totally. I feel like
in Canada.
Canada's a bit different, but I think at least in the United States, the demand for energy driven by AI adoption has kind of like, it's shattering all this like idiocy around how we've been doing things. And the biggest thing is more effective regulation and governance of nuclear energy, which is by far the most energy dense thing we could ever build. That's one thing. That's great. So getting that cheaper and more deployable is nice. But also like the learning rate on like solar and batteries is crazy. It's like getting, double-digit % cheaper every year or every 18 months, something like that.
So you see a world where you see a world where there's limitless energy, fusion energy. I mean, is there a world where the two coexist? I mean, because
so, I mean, like we have to think about like what the realistic like milestones, timelines are involved here. So most privately developed commercial fusion companies have an expectation of Q greater than 1, so energy onto the grid, net production by the mid 2030s, right?
Okay.
So that's like not really in time for the data center crunch.
Sure.
And I think there's a disconnect from people in software versus hardware with this interview with Greg Bachman, who was like at OpenAI, a big guy at OpenAI. He's like, oh, well, fusion's going to solve our energy problem. And it's like, not even the fusion scientists, not even the most ambitious fusion companies are telling anyone that like, yeah, our need for energy next year to build this data center is going to come from fusion. I think that is like the long-term solution to energy based on our current understanding of engineering and physics that is quite tractable. in the near term, though, I mean, solar is going to get cheaper and cheaper. Small modular reactions and fission reactors, that's like, that's 70 years old technology to be developed and deployed at greater, levels of safety and scale. But the different kinds of energy production methods occupy different areas of this like trade-off landscape, right? Like solar is very cheap for marginal deployments. Nuclear has to come in like larger amounts, but it's more stable. So because energy is always a local demand, it'll always have a regionally variable composition in the grid production capacity. Yeah.
So if we're thinking short term, you're most excited about this combination of battery technology, new technology to store energy and solar. Long term, this might...
I'm actually, I think like those are necessary and inevitable stepping stones in like scaling overall like industrial civilization. I'm not excited by those because they're extremely well understood and we kind of know the performance curves there and how good they can get into the future. There's other interesting research that I think would ultimately make every aspect of the current energy grid composition like completely irrelevant, which is like things like the Casimir effect, Casimir energy. And this is...
What's that?
Well, so empty space is not truly empty, but rather it's filled with an essentially unlimited number of different frequencies of electromagnetic energy. And we call these 0-point modes or 0-point energy.
Okay.
Now, the fact that empty space is filled with energy doesn't mean you can actually harness it. It may just be there as like the background, right? The background noise. Well, some people are trying to see if you can extract usable energy from the quantum vacuum, and they have some preliminary results suggesting that it may be possible. Now you think like, how does that make sense? Is this energy from nothing? Does this violate the second law of thermodynamics? No, actually, it doesn't. It doesn't violate fundamental physical laws, although that's kind of contentious in some ways. But that's the kind of thing where it's like, what is something that would upset everyone's assumption about the future? That would be an overnight new $1 trillion industry. It's something like that.
Should we expect one event during Deep Tech Week on that specific subject?
For New York, yeah, I'm going to try to pull this together.
Well, why New York? Because New York is more into energy.
No, it's just the next one.
Yeah. So maybe the one in San Francisco also will have one building on the one in New York.
This is part of my game with Deep Tech Week. It's not just to have like really well understood mature technologies or rapidly maturing things like semiconductors and robots. Like we know how that works. That's the future everyone expects. Me, really, I want to be like a sci-fi author guy, right? I'm into the science fiction. So it's like, well, what are the frontier physics things that may have a crazy impact 10 years from now that would completely upset, like things like a warp drive or like low energy nuclear reactions like cold fusion. These things that are like, they are totally on the fringe. They're not always as ready to invest in like electrogravitic propulsion or anti-gravity research. Like these things are incredibly, they're filled with like fringe theorists and hard to reproduce experiments. But it's like if our attention was to actually follow a constant curve in expectation value of things to understand, the potential outsized impact of those kinds of technologies, even if they have a 1% chance of working, demands a lot of attention.
To wrap this up, hyperstition, we talked about it. What does it mean? It means it's a word, but what?
Yeah.
You kind of said it just now.
Totally. So in contrast to a superstition, which is a false kind of narrative, often something fearful that it tries to control us or our behavior, a hyperstition is something that becomes true because you believe it. It is the self-fulfilling prophecy that we see in the writing of new science fiction, in the inspiration that gives to a generation of engineers and scientists that then motivates them to go build those things.
Andrew, where can we find out about Deep Tech Week? It's deeptechweek.com?
Yeah, separated by dashes. If you just search Deep Tech Week, it comes up pretty quick. Yeah,
Andrew,
totally.
Thank you so much for coming. This was a fascinating
Thanks, dude.
podcast. Hopefully next one lasts, 3-4 hours?
Yeah, let's do it. Awesome.